All right, welcome to Doozer Shop. I want to show you guys a vise that I have been working on and cleaning up for like 6 hours. It's a shaper vise or a planer vise, and well, I got this many years ago. It just sat on my floor and I never put the effort into cleaning it up. I found it on Craigslist or Marketplace or something. I think I paid like 125 bucks for it. It's very heavy. I bet you it's close to 150 pounds. And it's made in Russia, in the USSR. And I got it from my planer, my Rockford hydraulic open side planer. But it needed to be taken apart and like cleaned, and there's like a little metal chip stuck underneath the sliding jaw. And you know, it just was gungy, and you know, I cleaned up all the hardware. The bolts were, you know, cheap quality screws and bolts, and they were seized in there. Let me just take you handheld and show it to you. All right, my camera. All right, so I got it on the planer already. This is after many hours of cleaning and scraping down the whole outside of it. I think the gray is primer and the green is the actual paint, but it just was so old it came off. And I think what makes paint crack and come off is temperature changes. Like it's like brittle paint, and then the hot cold cycling makes it come off. But anyways, let me see here. It's made in Russia, as I said. Let's get you a shot of that. And I did some Google searching, and all that said is made in Russia. I forget what CCCP is. I forget. Central Soviet. No, I don't know what that is. But the actual the symbol, Google, which I don't trust 100%, said that's the symbol for Stanco Import Company. So Stanco, they import Russian lathes. They're in Canada, as far as I know. But anyways, really neat vise. It's like a 10-inch vise, right? Let me show you here. Sorry. So it's just shy of 10 inches. And you're gonna have to trust me. I open this and it opens to 11 1/4. So call it 10 by 11. The screw is enormous. That screw, that's 1.5 inches. I'm sure it's metric, you know, but really neat vise. I like that it has the swivel base, because on the planer you can use it both ways, sideways and you know, straight back and forth. This is not the most strong way to set a vise up on a planer or a shaper. Ideally, you know, the tool's pushing and pulling back and forth, and you want the force of the tool coming forward to be resisted by the solid non-moving jaw. So really this should be turned like that, 90 degrees, to get the most you know, rigidity and least deflection. One of the things I want to show you is these jaws are slit. They're not slit. They're a two-piece jaw, and you can see the diagonal line where there's the back jaw and the front jaw, and the front jaw and the back jaw. And what they do, so right in the body, in here and in there, is a spring plunger, right? And they were rusted in there, and I heated them up and let them cool, and as it was cooling it popped out on the one. It's pretty cool. But anyways, the front serrated portions that grip the work are actually the spring loaded up. So what happens is when the clamping force pushes down back, because of the angle, it also pushes down. So the springs force them up, and when you clamp your work, it sucks the work down to the, you know, the bed of the vise. So you don't have any loose parallels or whatever. Let me do this. Let me show you. I want to put the camera down and let's see. My camera's, I touched the screen and it's all crazy. All right. So watch the top right there, okay? Let me move you back. Watch the top. I'm going to crank it closed, okay? And when I reef on it, you'll see the top of the jaws go down. You see they go down? I'll release the pressure and they'll pop up. See? Down, up, down, up, down. It's not much, but you can see it. So that's what I wanted to show you, is the action of these jaws. Now my Girardi vise has the same type of jaws, actually. And it must be a European thing, or other than American thing, you know, with these type of pull-down jaws. It's not like a Kurt, because the Kurt really doesn't pull anything down except the entire movable jaw, which is down to begin with. So sometimes you'll see them up on O-rings to give it that spring. It's missing the spring component of the system, right? So anyways, you'll see the hex head screws in the middle towards the center. That's the stationary jaw, and the movable jaw that has the angle portion up and down is the slot head screws. And I had to make a screwdriver to get them loose, because holy heck, those were rusted, and you know, a normal screwdriver was not going to work. So both sides are the same, the movable jaw is the same, and because you adjust the slotted screws, you can see that's like I think an 8mm M8 screw, and it's got a little slug of aluminum that bears on the cross threads of the slot screw. So it is used to adjust them and lock. You tighten that up, and it's got a slot head also. You lock that down, prevents them from walking, you know, during usage. And like I said, the aluminum slugs were just destroyed, so I made 4 new ones. 1/4 inch diameter, 1/4 inch long, slipped them in there, nice aluminum, nice and soft, that, you know, put them in there. So the moving jaw, it has this, you know, oiler ball that feeds the nut, which is pretty neat. The nut is massive. Probably can't see it, but it's a massive nut. In length, you know, about 1.5 inches. It's probably what, 32 millimeters, I forget the metric equivalent. And it's got a taper pin, and yes, it was hard to discern the small end, and I hammered it tight initially, and then I quickly realized that that's the small end. 3/4 square, I guess you could say 19 millimeters, but 3/4 square on both sides. Let me jump around the other side real quick. Yes, on both sides. So kind of neat that it's got access on both sides for tightening or loosening. This little sheet, this is sheet metal cover. It's like a bell. Whatever. And there's a little bitty set screw, a 6mm screw that just holds it. So under the bell cover, under the cover, is a gigantic ball type thrust bearing and two gigantic Belleville cup washers, Belleville springs. So when you tighten the whole works, it loads the thrust bearing, of course, and it also compresses the discs, the Belleville washers, the Belleville springs, to give you. It feels good when you tighten it. I think that's kind of why it does it. Yeah, man, look at that big beefy screw going into that big beefy nut, and it's a cast iron nut, and a steel screw. So that's cool. It's got this rotating base, as I mentioned. These T-bolts were very tight, and these nuts on the T-bolts, I should say, were very tight. I think they're a little bit soft, and the threads were stretched a little. But I used penetrating oil, and then it was still getting tight, and I think it needed more lubrication. So I put some black moly oil on there. And then I kept going back and forth with the wrench, you know. So then I took everything apart, cleaned them in the parts washer, mineral spirits, blew them off with compressed air to remove any particles or grit or whatever. And same with the washers. And I put the nuts on upside down, thinking it'll give the other side of the thread a nice free surface to be used again. Maybe, I don't know, whatever. So I know you can't see, but I made these T nuts that go in the T slots. I made them a while ago, and I finally threaded them for 5/8 11. And I made these studs. I had some threaded rod, some actually B7 grade threaded rod, and I cut them on the lathe, on the bandsaw, and I faced them on the lathe. And I don't know why I put centers in it, just because it's cute. Nice heavy hex bolts, nuts rather, and thick washers. The thing is, when you rotate this thing, this right, let me kneel down. The bottom, when it rotates, this side and actually the far side over there too, it gets really close to the top of that nut and that stud. So you have to cut it, you know, you make your stud the right perfect length. The way it is now, I got a full thread, and I'm sticking up about 1/8, and I got about a 1/16 of clearance under there. So it will swivel, but you just had to be careful and figure out, you know, exactly how to make your studs. So anyhow, that's my vise. One thing I wanted to mention, because these jaws move up and down, you don't want to tram with an indicator. You don't want to tram your vise against there. So what I did is I put an indicator on the tool holder, right? I put an indicator, a mag base, I just stuck it anywhere on this tool holder, and then I trammed the side, actually it was the back side, but you get the idea, the side of the vise bed, right? The side rail of the bed, I trammed that. So you just traverse the whole planer head side to side with your indicator on the tool holder, right? And that sweeps, you know, it sweeps in the back side. I mean, you could do the front side too, it doesn't matter. But at least you're on, you know, a known perpendicular surface, you know, because the way these jaws wedge up and down, there's no guaranteeing that they're parallel in the up condition. When they're sucked down all the way, I believe they're pretty darn close to good. But anyhow, let me go on the other side again. I guess I'll show you one more thing I got in my mind here to show you guys. I actually had a it was like I think it was eBay, or it was an estate sale that, and this woman was hosting this stuff on eBay, and she's from up in New York. I thought it was pretty cool. And I got a bunch of these, they're big and wide parallels, right? So I said this vise is 10 inches wide, and these are every bit of that. They're just perfect. Okay, and then my piece that I want to plane, well, I could have done a better job of setting this up. Alright. Alright. So, you know, I'm one-handed here with this camera situation. Let's crank it up. Alright, so let me push this so it's kind of in there. Push that so it's in there. That's there. I guess that's flush enough. And they give it the old squeezerooski. Ooh, I heard them. Ah! That helps when you make that sound. So if everything is proper and good, oh yeah, you cannot. These parallels are just sucked down tight. Try that with a Kurt vise, right? These vices work, man. I'm impressed with this. I can't wait to use my Girardi vise on different things where it has the same suck down feature. Now I notice on the Kurt, some of the newer Kurts, on the hard jaw, on the movable, you know, portion of the vise, there's little O-ring grooves they can stick O-rings, so it keeps that jaw just up a little bit off the vise, so it gives it room to be up and then to suck down. You really need it more on the moving jaw. On the stationary jaw, I don't believe you really need that type of jaw as much as, because this movable jaw is up and down because it's got to travel. The stationary jaw, hence the name, stationary, and it's not moving, but I don't, I like how it works, man. I set the travel on this one a little bit less, and I set the travel on this jaw a little bit more, and man, I think it's perfect. It's really, really on there. So this, let me show you something. There's no bearing, there's no force going on here. It's all taken up by the other side with the thrust bearing, okay? So this collar, there's actually a gap in there when you tighten it. You can kind of see, maybe you can't, but there's a gap in there. Now, I want to kind of illustrate something. So you hear milling vise and shaper vise or planer vise. What makes this a planer shaper vise is the fact that the screw is in tension. Because when you tighten it, it's pulling off the stationary jaw, right? The moving jaw is being pulled by the screw, right? So there's the nut and the screw, and the anchor point of the screw is the stationary jaw, and it's, you know, pulling together. So the screw is in tension, putting the part in compression, right? Now a milling vise, like a Kurt vise or whatever, let's go walk over, because why not? Now a Kurt vise, the thrust is taken up on the back side of the body, right? The bearing for thrust is right in there. So when you tighten the jaw on a Kurt vise, you're pushing from the back. You're not, you know, pulling from the front. Let me show you. It's got a plastic plug on there, but that's where the nut, or that's where the nut is, and the screw travels, and that's all part of the moving jaw. I know it looks like it's the stationary jaw, but that nut goes all the way back to the moving jaw. So what you're doing is when you're tightening a Kurt vise, you're clamping obviously between the jaws. The body is in tension. It's pulling the body apart. Is that right? No, let's think about this. So the screw is in compression. Yeah. Is that right? So if the jaw has got the nut in it and it's being forced shut, so it's pushing this way, so the nut is in compression and it's forcing that back, which is pulling the body. So the body's in tension, the screw is in compression, because the screw is pushing the jaw closed and it's pushing against the body, and then the body is pulling away from the stationary jaw, so the body's in tension and the screw is in compression. That's the opposite of the of a planar vise, right? So I just wanted to show you the difference, and I got to think about it when I explain it, because it's not evident all the time, and it's not something we think about all the time. So the advantage of a shaper vise is the body does not have to be strong. The strength comes from the screw, and the screw, you know, is metal. It's steel. It's in tension, right? And if you put your screw in tension, it's going to want to stay straight, and that's, you know, metal's very strong in tension, but it's strong in compression too. But the thing is, if you put it in compression, it's going to want to squiggle, right? It's going to want to buckle. We make them big enough in our designs where it's not going to do that, but that's always the tendency. Well, I talked for over 20 minutes about a silly little vise, but I just wanted to highlight that, and I'm kind of proud showing it all finished up. I'm not going to, it's very clean. I'm not going to paint it, whatever. I'm just going to use it. So I owe you guys a planer video. I have no excuse not to run the planer and show you guys how this bad boy cuts. So anyhow, I hope you enjoyed my little dissertation on a vise for the planer. Until next time, this is Doozer's Shop.